Okay, everybody, here we go. So here is our lab on electricity with series and parallel circuits. The idea is this. You are going to understand better as we go through this lab with series and parallel. Understand with a parallel circuit, the voltages stay the same throughout and the currents add up to a total. With a series circuit, the currents stay the same throughout and the voltages add up to a total. Okay, a couple things about the light bulbs. Now, because of so many years of people knowing different wattages, we sell light bulbs as 40-watt light bulb, 75-watt light bulb, 100-watt light bulb. All of these things are because your parents, your grandparents, and before that, people knew, all right, well, I wanted a really bright light, and I know what a 100-watt light bulb looks like. I want that kind of brightness in this room. Something lower end, I just need a softer light. Maybe I'll just do a 40-watt. So you have been trained, your parents have been trained to know what to expect. The thing is, things have changed. Okay, so all light bulbs now are actually more energy efficient than what they're supposed to be. So when you see a light bulb and you see 40 watts, it's actually going to say 40-watt equivalent. Okay, and now obviously we have LEDs, but even regular incandescent light bulbs actually are more efficient now, but they will still say the 40 watts up there in bold because you know what the kind of brightness you want with a 40-watt light bulb. Okay, now what is stamped on a light bulb is going to be with an expectation. Okay, so we'll ignore the whole energy efficiency and we'll just assume these are 40-watt light bulbs here. Okay, but even with that, it's with the understanding that you are in the United States of America, and you know that in the United States of America, you get 120 volts. And the second thing is you know that all light bulbs must be wired in parallel. Okay, if you had light bulbs not wired in parallel, one went out, they'd all go out. If you unscrewed one light bulb, all the light bulbs would go out. You don't want that. Okay, so when you have that stamp on there, it's an assumption, but it's a good assumption. And it's an assumption we can use to do our calculations, at least in parts 1 and 2 of this lab. Okay, so what we're going to do is this. I'm going to do the lab here. You are going to draw the lab and draw the circuit for each one. And I'll give you time to do that. And you'll pause me so you can draw each circuit. Then after we're done doing all of the labs and demonstration, you'll go back and you'll do the calculations on there. And I have a separate video on how to do each calculation. Okay? All right. So we're going to do part 1 right now. Part 1 is going to be 3 40-watt light bulbs wired in parallel. So what I want you to do is I want you to right now draw at the top of your first paper, draw that circuit, 3 40-watt light bulbs in parallel. It should be 3 resistors wired in parallel to a voltage supply. So I'm going to pause it here, or you're going to pause it here. Pause me here and draw your circuit, and let's see how you do. Okay, we're back. How did you do? Did you draw 3 resistors that look like a ladder, okay, in parallel with a voltage supply? And you can put numbers next to them. You can put 40 watt, 40 watt, 40 watt, and you can put it in parallel with 120 volts because we know it's 120 volts. Did you wire that properly in parallel? Does it look like this? Okay, good. All right, so now we're going to go ahead and plug it in. I'm going to get my handy assistant to come over here and turn the lights off for me. Thank you, handy assistant. And here we go. So here are our 3 40-watt light bulbs wired in parallel. Amazing, huh? A light bulb on. Okay, good. Okay, so now what we're going to do is we're going to change light bulbs. And I'm going to do, this is part 2, we're going to change out one of the 40-watt light bulbs for a 75-watt light bulb. Okay, so we take one out and we plug another one in. So this next circuit, I want you to go halfway down your paper so you have plenty of space to write. So for this next one, you're going to draw 40, 40, 75 in parallel. Again, the voltage should be the same. Okay. The only thing different will be you'd have the numbers will be 40, 40, 75 now. Okay, so go ahead and pause the video here. Okay, did you draw the circuit? It should look like this. All right. So here we go. Now, let's plug it in. Let's have my assistant turn off the lights for me. And we plug it in, and here's 40, 40, 75. Now, it might be hard to tell, but the 75 is much brighter. Okay, does that make sense? So there you go. Amazing. A 75 watt light bulb is brighter than a 40. Cool. Okay. All right. Now, before we turn the lights back on, let's see if we still understand parallel circuits. If I take one of these light bulbs out, the others should stay on. So we knew that from before, right? Parallel lights, if one goes out, the others will stay on. Okay, so make sure you're going to leave space. We're going to move on to our next circuit now. Part 3. Now we have 3 lights in series. So in series, it's going to act a little differently than in parallel. All right. Now, what we can no longer do is assume that these light bulbs are giving off the watts that they say on them. Okay, so these are 375 watt light bulbs, but when you draw it, you're going to have to draw those 375 watt light bulbs with quotes, okay, on them, because we're labeling as 75 watts, but we can no longer assume that they're giving off 75 watts because they're in series now. So I want you now to draw 3 resistors in series with our voltage supply, which is still 120 volts, okay? But go ahead and pause me here and draw what 3 resistors will look like in series with 120 volts. Okay, how do we do? It should look like this. Okay, you should see it, and you should see if you trace your finger along, you should be able to have that current running through the same spot the whole time. Okay, now we are now going to plug it in. So here we go. We have 75 or 75, 75, 75 in series. So we're going to have my assistant turn off the lights. And voila. 75, 75, 75 in series. Okay, we can no longer assume that they're going to give off actually 75. And let's see if it's really in series. If I take one out, hey, look at that. They all go out. So it's wired properly. Yay me. Okay, so now what we're going to do is I'm going to have the lights turned back on for my wonderful assistant. I am going to take away a 75 and I'm going to replace it with a 40 watt. Okay, so now I'm going to have 75, 75, 40 in series, not parallel. So I need you to draw this 75, 75, 40 in series with your power supply. Okay, and pause me here to go ahead and draw that. Okay, how'd it do? Does it look good? Let me see yours. Oh, okay, good. That's fine. Okay, but you should have it drawn out. It should look like this. Good. Okay, here we go. So now, before I plug this in, I want you to think about what you think you will see. Okay, if we have 75, 75, 40, you remember what you just saw in the last one when it was in series. I want you to close your eyes for a second and guess what you think it's going to look like. Got it? Okay, here we go. Trusty assistant's going to turn off the lights. How do we do? 75 watts, 75 watts, 40 watts. Is that what you guessed? Okay. So what you're going to do in this lab is now draw and do all the calculations. My assistant will turn the lights back on. Thank you, assistant. And you're going to draw all 3 of these and do all the calculations. Okay, now when you do this lab, you need to understand that the first first parts 1 and 2, you can use the numbers we gave you. Okay, you can use the watts that were stamped on it. You can use the 40 watts in part 1. You can use the 75 as well. You can use those numbers. When you move to 3 and 4, the only thing that can transfer over, you can no longer assume that the watts are going to be correct. However, you can still assume that the resistance, when you calculate the resistance in parts 1 and 2, you can take those over in parts 3 and 4. Okay, I have a whole playlist of videos on how to solve these problems. And the sheets will be on my website, and I'll also put it in the description. I'll link to this lab in my description. But you need to do all the calculations now, and let's see how you do. All right, good luck.